In this video, we're going to look at a new thing you might have heard before, but it's called factoring. And factoring is going to be the focus of the rest of the unit. So far in this unit, we've done a lot of combining expressions, multiplying things with FOIL and multiplying bigger polynomials together. But in the follow learning, we're going to do the opposite. We're going to factor our expressions, which is breaking it down into its smaller component parts. So the things that you'd have to multiply together to get to that. So it's the exact opposite of what we were doing before. This isn't what we'll be doing for the skill checks and stuff, but show what do I mean by factoring. 30 is a number. But 30 I can break up into 10 times 3. And 10 I can break up into 5 times 2. So the fully factored version of 30 would be there's a copy of a 2 times a copy of a 3 times a copy of a 5. This is what we mean by factoring. We're taking this big composite thing, which is a bunch of numbers combined, and saying what things do we multiply together to get that big term. It's not going to be as simple once we start mixing in variables, but the idea is the same. I'm taking one thing and breaking it up into its single pieces that need to be multiplied together. So the thing we're going to do first is talk about the greatest common factor, known as the GCF. Again, greatest common factor is long, so I'll just abbreviate it. It's the largest term that will evenly divide all of the terms of your expression. So evenly means you're not going to get any decimals or fractions, and of course all means every single one. Our first step is factoring the GCF. So we're going to take this greatest common factor and pull it away from everything else. So let's see what I mean by that. So the first thing we do is figure out the GCF and then factor it out. So what we can generally do is the variable part separate from the number part. So if we just look at the numbers, 5 and 10, we're thinking about the biggest number that divides both of those numbers. You can go through 1, 2, 3, 4, 5, but hopefully you can see that the number that divides 5 and 10 is 5. And the variable parts, well, there's no variable part here, so there's no relation between the variables, so the numbers are all we can really do in this problem. So what we're going to do is this 5 is our common factor. What we're going to do is pull it away, so kind of the reverse of the distributive property. So the distributive property, I had arrows do this a lot. When we're factoring, the arrow is going the other way. I'm pulling it away from both these terms. Now this 5 is going to come out in front of the parentheses. And then what's left behind, again with foiling, we're multiplying, so here we're kind of dividing. I divide 5 by 5 and I just get 1, so there's going to be a single x there because I got rid of that 5. And 10, I'm getting rid of a 5. Again, I'm not subtracting 5 and dividing by 5 is going to leave a 2. So I pulled out this common 5 and left behind an x plus 2. One way you can check yourself whenever you factor, you can check your answer by going back and distributing. If I distribute this in now, I'll get 5 times x is 5x, 5 times 2 is 10. So whenever you factor, you can check your answer by just multiplying again and making sure you get back to where you started. Here's another example. Find the GCF and then factor it out. Again, the numbers would be first. If there's no number in front, there's just a 1. So what's the biggest number that divides 3 and 1? It's just going to be 1. But what about the x's? X squared is 2 copies of x. X cubed is 3 copies of x. So the greatest thing that they have in common is 2 copies of x. So I'm going to get a factor of 1x squared out of this expression. And again, I don't have to write the 1, so I'll just write x squared. And think about your dividing out that term. So if I have x squared and I get rid of x squared, well, those are just going to go away. And I'll just get that 3. And for x cubed, there's 3 copies of x, and I'm getting rid of 2 of them, so now there's just 1 copy of x. So when I pull out that common x squared, I get left behind with 3 plus x. So here's one to try on your own. Find the GCF and then factor 8x plus 4. And here's the final answer. So the GCF you end up finding is 4 because it divides 8 and 4. So you're pulling that 4 out of both these terms. The most common mistake students will make is they're pulling a 4 out of a 4, so you might think you get a 0. But again, when you're factoring out, you're thinking about division. So I'm taking 4 and dividing a 4 out. That gives me a 1. So if you pull out an entire term that you have, you get a 1, not a 0. And 8 times 4 is 2. So that's why we have the 4 out in the front and 2x plus 1 in parentheses. And again, you can always check yourself by distributing this back in and seeing you get the same thing that you started with. All right, now there's multiple terms, but the idea is still the same. I'm looking for something that divides all 3 of the terms. In this case, every single term I have, if there's 8 terms, you'd have to find something that divides all 8 terms. So again, I do the number part separately from the variable part. So first I'll just look at the numbers 3, 9, and -6. All right, what's the number that divides all 3 of those numbers? And it turns out to be 3. And this is a part that can take a little bit of guess and check. All right, might take you longer. Eventually you'll get used to it and figure out really quickly what number you're going to be pulling out. But you think about 3, 9, and 6. Generally start with the smallest number first. Or what are ways you can divide 3 and see if they also divide the other numbers. Luckily here, the only number that divides 3 is 3. And it divides all the other ones. And then the next thing I'll do is look at the variable parts. Again, you don't have to do this every single time, but I'll just write it down. X squared is 2 copies of x. X cubed is 3. And x to the 4th is 4. And we'll see the biggest thing they all have in common is 2 copies of x. All right, so what I'm going to be able to pull out is 3x squared. All right, this is my GCF, my greatest common factor. And what's left behind? All right, well, I'm pulling out a 3x squared from 3x squared, so we're going to divide out 3x squared. I'm just going to get left behind with a 1. 9 divided by 3 is 3, so a 3 is left over. X cubed, take out x squared, is just a single x. And then I have a minus. All right, 6 divided by 3 is 2. X to the 4th, taking out x squared is going to be, maybe I have 2 copies of x is x squared. All right, so this is our final answer, the factored form of that expression. And again, check your answer by distributing in and making sure you get back where you started. All right, another example, same idea. Look at the numbers separately from the variables. And I actually think this one's going to end up being the same. The biggest number that divides all 3 of these. All right, well, 1 always works. 2 doesn't work because it doesn't divide 9. 9 works for, sorry, not 9. 3 works for all of these. All right, 4 doesn't work. It works for this one, but not these ones. 5 doesn't work for any, and then 6 is the number we have here. So the biggest number that's going to divide all 3 is 3. We have x to the 4th, x to the 5th, and x squared. Generally for the variables, what you're going to be able to factor out is whatever the smallest number is. So we're going to be able to factor out x squared. And again, just think about dividing it out. So 12 divided by 3 is 4. X to the 4th, getting rid of 2 x's, leaves me with 2 x's still. 6 divided by 3 is 2. And then x to the 5th, getting rid of 2 is x cubed. 9 divided by 3 is 3. And we got rid of the x squared, so it's not there anymore. All right, so that's our final answer. We put out the GCF 3x squared, and we get left with that term in parentheses. All right, one thing you should kind of check as you go through is this actually fully factored? Is there anything else left? So let's just say our example was we factored it and we got down to here. All right, it would be a different problem, but you can see these still are all divisible by 2, so you'd also want to pull a 2 out. All right, but just keep being willing to factor until you look at this and you say there's nothing in common anymore. There's no numbers that divide 4, 2, and 3. And there's no x's in all of the problems. So that's how I know I'm done. I can't factor anything else out. All right, so here's one for you to try on your own. All right, factor out or find the GCF and then factor it out. All right, here's the answer I got. So the GCF is 2x because 2 divides all the numbers and a single x is shared between all those. And again, 4 divided by 4 is 2. 2 divided by 2 is 1, 8 divided by 2 is 3, and then just getting rid of those powers of x for each one to get your final answer. All right, so time to practice. All right, factoring out the greatest common factor is a very important skill. All right, we'll learn other types of factoring in future learning objectives, but it's always going to start with the GCF. I do that first, and then you can do all the other types of factoring we learn. All right, also, just factoring in general is a really important skill for all of your math classes.